So last year we started discussing L systems, right? Yep. So there are many L systems. For instance, context insensitive, context sensitive, stochastic, and deterministic algebra. So we started discussing, deterministic, context insensitive L systems. Right? Yeah. So if you have an L system, so we know that there's an alphabet, right? So we have this tuple, or we have this tree tuple, alphabet and initial or axiom. This is called axiom or initial word. And this is the production set. This is called production set or set of rules. This is initial word, and this consists of symbols. It has variables as well as constants, right? So if it is a variable, then that they are involved in production set. Yeah. So A is a variable. So then you can assign. Yeah. So there's a rule for the symbol. That's why we call it variable. Otherwise, we call so we call constants. So they so you don't have any rules for constants. You have rules for variables, right? But in this grammar, in this L system, you have how many characters or symbols? One, two, three, four. Four symbols. So using these four symbols, so you generate words. So this is the initial word you have. Yep. So and you have set of rules. So by applying these rules, you can generate. So rewrites. These are called rewrite. First rewrite, initial word, and first rewrite or first iteration. Second iteration or second rewrite. Third rewrite. Okay. Okay. So let me pause a little bit. Okay. Yep. So now we are going to discuss this stochastic systems. So far we have discussed deterministic, context insensitive. Yeah, this one also context insensitive. Yep. So why I'm saying this is deterministic? Yeah. So here A is replaced with this. So definitely if you encounter this letter, so you have to definitely change this letter to this one here. Definitely, right? Definitely. But in stochastic, yeah, there's a probability, right? There's a probability. Yeah, so here this is an example of deterministic systems. So if you encounter letter F, yeah, you have to change F to this bit here, certainly, right? But in yeah, that's why you get these type of symmetric, yeah, lights, right? So this is the second iteration or rewrite, or third rewrite, fourth rewrite, right? Yeah. So this is the visualization of that word, second rewrite, visualization of the second rewrite. So this is the visualization. If you define these F pluses and minus meaningfully, yeah, you can visualize those rewrites, right? This way. Okay. So that was deterministic L systems. Deterministic L systems. Now let's discuss the stochastic systems. And this one also context free or context insensitive, right? So, all right, here we go. So let me Take a simple example. Yeah, let's define a small uh, stochastic. So like this. So initial word is F. They have only F. Yep. So K is fine. Yep. So this is your initial word. Uh-huh. So the alphabet, and we have how many symbols? Alphabet set are denoted as a F consists of F character F plus and minus. So this is my alphabet. Yeah, no other letters. Ah, yeah. So brackets. Let's forget brackets for a moment. I think our teachers will explain. So what are those? Yeah, if I am with you today. Yeah, so I will explain later after discussing stochastic. Yep, these brackets, those brackets, and yeah. Let's assume we have these three symbols in our alphabets. Yeah, yeah. So this is our initial word, and let's define the production set. That means the set of rules. If you encounter, yeah, if is a variable, if you encounter, so this replaced with, let's say, a plus and minus. Yeah, yeah. So there is only, yeah, so one variable. Yeah, that's why there we have only one rule for that variable. Ah, no. So this is probably, yeah, stochastic. Yeah. Then there's a probability. Yeah. So there's a probability of replacing. Yeah. If with this garbage, yeah. So let's define a probability. Yeah. 75. Yeah. 75%. 75%. Yeah. Point. Yeah. 0.75. Right. And right. Right. So this is rule one. Rule, let's say this is rule. Yeah, let's say this is rule zero, and this is rule one. Of course, this is yeah, so stochastic. If the probabilities is let's say 0.25, yeah, this will change to yeah, so something else. Okay. Yeah. All right. So this is the stochastic. So how do you generate rewrites? Yeah, I forgot to get my writing board. Let me get my writing board. Writing pad. Wait a second. Wait, pause the go. Right. So there's a probability. Yeah, changing this letter to this. There's a 70. Yeah, there's a yeah 0.75. Yeah, probability changing F to this thing and another 0.25, yeah, or 25% changing this letter to this. Okay, let's so for this you need random numbers. Yep, so I will generate some random numbers. Let's say plus yep, so we change one. Okay. So I have set of random numbers. Okay, this is my set of random numbers. Okay, so I will use this set of random numbers to to generate rewrites. So how do you how do you apply this rules? So there are two rules for this letter. So how do you apply for this rule? Okay, let's apply. Okay, so let me write to you. So when you so when you rewrite, oh my, what is so when you rewrite this f, so we apply we have this one here. So we will apply this one. We use rule zero R0 whenever our random number is less than less than 75%. Okay, I will use we apply this. I will use no rule, right? If my random number, so I will define my random number as epsilon. Epsilon is less than or equal 75%. So I will use other rule. One, if the random number is greater than, yep, so uh, greater than 70. So, okay, then you can, so then you can generate, so this is so you have two rules for f. So, so if the random number is less than 0.75, you have to use this rule. If the random number is greater than 0.75, you have to use this rule. Okay, what is the initial word? Very simple, f. Yep. So this is your axiom or initial word. Okay. So how do you obtain the first rewrite? Okay, let's apply. F. There are two rules for f. Now we have to look at the random number. So let's look at the random number, which is, let me get, so this is my first random number. Okay, 0.49 something, which is less than 0.75. That means, yep, so, so that means, so that means, so that means I have to use R0. So rule. So then F is replaced with F plus F plus F minus Yeah, so this is your first rule. Yeah, F minus. Yeah, this is your first rewrite. Okay, after using these random numbers, yep, so I have to use you cross this off. So I will cross this off. I use that. Okay, right. Then I will generate the next rewrite W2. Yep, so again, so when I read this rewrite or this word from left to right, so I first encounter this character, okay, the symbols. So there's a rule for the symbol, but yeah, this is the rule because it is a variable, right? So now, okay, so that depends on this random number. So, so we don't know. We have to use the first rule or second rule. So that depends on the random number. We look at the random number. Yeah, so which is okay, which is less than 0.75. I use that. Then okay, then I use that. Then I have to use not, which is this thing. Okay. Then F is replaced with F plus F minus. Okay. And and the second character is this, which is a constant. Yeah, I leave as it is. Okay. And the next one, yeah, F. Okay, F. For F, there are two rules. Two, yeah, so there are two rules. But to identify which rule we have to use, we have to look at the random number, right? Random number. Let's go to the random number. Okay, this number also, this random number is less than 0.7 again. Yep, so again we had to use, yeah, no, this rule. So let's use this rule here. F plus F minus, yeah, this one. And this is a constant. Yeah, we leave as it is. Yes. Yeah, this is my second rewrite. Okay. And third, let's generate the third rewrite. So you have to write a code to generate this. How do you write? So that is my question. Yep. So you can do that because you are smarter than us. Yeah, definitely. I know all of you. Oh my God, you are genius. Yeah, no doubt about it. Yeah, so you can teach me actually. So we know nothing about these things. But you are in 21st century students. Yeah. You are you born with your computers, laptops, and so you're born with your so very smart, not like us. Yeah. So okay, so coding bit is very simple. I think for you, I think for me. All right, so okay, let's see how it goes. Yep. So the second session. Right. So let's read this to generate the next iteration. Read this from left to right. So we are not. We don't write. We don't read from right to left. So not Arabic. So this is the so from here to there. Okay. So F. If there are two rules, so which rule we have to apply? So that depends on the random probability. Okay, oh my God, everything is less than 7. Let's let's assume this is 7.75, right? 0.75. Let's assume, right? Okay, otherwise all the time you get the same. Let's assume this is, yeah, 0.75. Let's pretend this number, yeah, 0.75 something. Okay, then, okay, this random number is bigger than 0.75. Then you have to use rule number one. Yeah, so R1. So what is that? Yeah, so F is replaced with double F. So this is a constant, leave as it is. And again F, yeah, F, if you want to find the rule, we have to look at this. So after using this, make sure that you cross this off. So use this number, this random number. Then, yeah, cross this off. This is, so we are going to use this random number. Okay, which is less than 0.75, then, yeah, which is less than 0.75, then F is replaced with this garbage. It's garbage. Like that. Yep. So yeah, you can do this. Yep. So negative residue, because these are constants. Again, you have F. Yep. So how do you decide? Yep. So rule. Yep. So we have to look at this. Yep. Yeah, like that, you can generate these rewrites. The thing is, yeah, so this is a tedious work. We cannot do it by hand. So we have to code this process. So how do you go? How do you write this? So how do you write a code to get these rewrites? After getting these rewrites, then after getting these rewrites, let's say 4, 5, or let's say W10, 10th rewrite, right? So let's say someone wants to visualize this word. So how do you visualize? For that, you have to define these F. So how many characters? Yep. So F plus minus. Yep. So you have to define F plus and minus meaningfully to visualize the turtle graph or visualize these words, these rewrites. Yep. So this is more related to, yeah, computer science. Yep. So how do you develop a code using Octave? You are using Octave. You use Octave in this course. So how do you develop? I think I'm pretty sure you can do that. Yeah, pretty sure, because all the time you use phones and laptops. Yep. So and I don't have a phone. Yep. So I don't like to use a phone. So yep. So can you please explain how to take the no value again? These values, or so here, so they define probabilities like this. F is replaced with this whenever the random number is less than 0.75. F is replaced with double F whenever the random number is greater than 0.75, right? So you have to check the random number all the time. Let's generate another set of random numbers. Yep. So here, Okay, here the second one is greater than zero point 0.7. Okay, okay. Mm, yeah. So here, okay. So don't you understand? Didn't you understand this? So okay, let me pause the. Yep. So what's the difference between deterministic and stochastic? Yep. So deterministic systems, yeah, you can see these kind of symmetries. But if you look at the objects, or if you look at the plants in nature, you don't find these symmetries all the time. So we find these non-symmetric. Yeah. So these are not yeah, symmetrical objects around this axis. Yep. So you here. Yep. So in the nature you cannot find yeah symmetrical objects all the time. So we get different variant objects, a variety of objects, plants like this. That's why we incorporate yeah probability part. When you apply these rules, we incorporate, include the probability bit to get these kind of different plants. So let's let yeah. So here we have this yeah branch, but we don't have this branch here. So these are so more natural objects. So if you want to yeah so generate more natural objects, you have to include stochastic bit as well. You have to consider stochastic or probability bit. So this, yeah, so then you get more natural yeah, structures, natural structure. So very similar with the objects you see in the environment. So that's why stochastic is very important, right? If you want to produce yeah, so natural objects, generate objects, you include a probability. Right. Anyway, so